Hello?
Hey, how's it going?
It's going pretty good. How are you?
Oh, I'm doing all right. Been a bit sick, so just getting over it.
No worries.
Finally. Um, hey, have you used this platform before?
I have not. This is my first time. How about you?
No, I've used it quite a bit. So, let's see. I want to basically gonna go over how it works quickly. You already set it to JavaScript, so good. So it's for me, it's the typical like 45-minute tech interview, but since intro is 5 minutes, and Q&A at the end is 5 minutes. It's really 35 minutes of tech. Um,
Yeah.
so we'll get started with that. I see you're an experienced engineer, and then at the end, I could give you your feedback, and then you'll get the chance to ask me any questions on it, or we could discuss it. Sound good?
Cool.
Awesome.
Yeah, sounds great.
So I'm gonna start you out with, well, I don't know JavaScript, so this is just kind of a guess what
Okay.
it is. Uh,
That's fair.
so I'm gonna give you a point class. Or you can write it as a 2D array or 1D array or whatever. So this will just be like an int X and int Y, right? Um,
Okay.
and then knowing that, I'm gonna give you a list of points. So that'll be something like 0, 1, 1, -3, 2, 4, 13, or let's say 1, 1, and 13, 2, maybe 2, right? Then I'm gonna give you the point origin, which will be, let's say, 1, 1, and then int
Mhm.
k, let's say, for example, 2. What I want you to do is find the k closest points around the origin based on distance, and just return
Okay.
those points. So in this case, it would be like 0, 1, and 1, 1.
Okay. So you give me a K, and so I want to find the K closest points. Got it. By
Yes.
distance. Okay, cool. So I will just probably comment all of that out because that's not JavaScript.
Yeah.
Okay.
I don't know JavaScript, so you have to translate that yourself to whatever JavaScript does.
Yeah. Yeah, got it. No worries. Cool. So I think seems pretty straightforward to me. Um, so I think the first thing is figuring out the distance formula, which the distance between 2 points, I believe, is b2 minus b1. Oh, that didn't work. b1 squared minus or plus a2 minus a1 squared, and then square root that. So I believe, can I do this? All right, I believe that's the formula for distance between 2 points.
Yeah, that looks about right.
So we'll start with that. Yeah. Okay, cool. So we'll start with that. I think that's pretty important. So the first thing so I'll think about what the algorithm looks like. So I've got a list of points, and you're giving me an origin point. So I think I'm just going to start by translating what you've written into something that's a bit more JavaScripty. So the function, first of all, is find k closest points, and you're going to give me a points array, and you're going to give me k, and you're giving me an origin, which presumably is a point inside of, inside of the points guy.
It doesn't have to be.
So
it could or could not.
It doesn't.
Be.
Oh, okay. Okay, got it. Okay, got it. Doesn't have to. Okay. So the origin isn't necessarily inside. So one of the points could be the same as the origin. The distance would be 0, and that would be one of the closest ones, presumably.
Yeah. And there could be duplicates as well.
Okay.
There could be duplicate distances
right.
as well.
Right. Got it. And in the case where there's duplicate distances, so say k is 1 and there's 2 that are the same, which do you want me to return, or do you want me to return both?
Um, it doesn't matter. Just return up to k. So if you have
Okay,
duplicates, then you can just return partials. So
got it.
like if there was
Okay,
three,
so my
you have two left. Just return any of the two.
got it. Cool. And so I'm thinking off the bat that my formula is basically go through the array of points, and so iterate over the array of points, calculate the distance from the origin for each of them, and I guess I need to map the distances to the points that they originated from, and then I can sort the array um, based on the distance. So basically that looks like, I mean, that's one way to do it. And the time complexity of that would be n log n, because sorting is n log n, and iterating once is n, and n log n is more. So it's just n log n. So that method would yield n log n with probably n space complexity as well. Does that make sense to start with?
Yeah, that makes sense.
Okay.
And
Cool.
sounds good.
Okay. Cool. So I guess there's edge cases as well, which I can handle, which are like if there are no points. If there's no points array, I'd probably throw an error. So there's that. If there are less points than k, less than or equal to k, then I can just return points. That's kind of a quick exit early strategy. And I guess, do you want me to throw an error if points are less than k because you wanted k? I could handle that different ways depending on what this was being used for. So potentially if it was less, I might want to throw an error and say not enough points. If it's equal, I might want to just return points. So I don't know, how do you want me to deal with that?
Let's leave it at that.
Cool.
So,
okay,
yeah,
so there's that. Yeah.
Both.
Got it. Cool. So I'm going to represent a point as kind of like you had it. A point is x, y as an array, and the array or points is essentially an array of these, like what you had below, and origin is going to be one of those points as well.
Yep.
So I will first start, I think at this point, actually I'll just do the iteration. So I'm going to have like a stub for a function here that's calculate distance from origin to points, and I will implement this later using this formula here. All right. Okay, so I'm now going to, as I said, iterate over this array, points over the points array, and get the distances added into them, points with distances. I guess actually there's another possibility for an error, which is that there's no origin. So I'll just throw an error for that as well. Can you see my cursor, by the way, or you just see what I'm typing?
No, I see the cursor. Every time you highlight, I see what you highlight. So.
Cool. Okay.
Pretty neat
so if there's no origin, we throw in a point. Yeah. I like this practice. This is nice.
Yeah.
Before it matters. So here's a point. I'm going to map over this, and distance to origin is going to be this guy. Origin point. And now I'm going to return the point, and the distance will be, I'll just make it distance origin as well. Cool, so that'll just like expand to this basically, an object. Cool, so now I've got my points with distance, and so at this point, it's an array of guys that look like this. So now I can sort this, sorted points. Oops. Sort, be return. Okay, so we want the smaller distance to be sorted earlier. So that would be want a negative. So if I do a minus b, so if b is 5 and a is 3, I want a to come out in front, so I want it to be negative. So that's correct. A minus b, 5 minus 3, that would give me -2, which would put it in front. Yeah, that's correct. Cool. So now I've got my sorted points, and I can just basically slice off the start of this array from 0 to k. Okay, so do you want me to implement this guy as well?
Yeah, pretty quick, right?
Okay, cool. All right, so this will be.
So I have a quick question right here at line 30. Would it be a minus b or would it be something else? Because you're doing a point and distance, right?
Oh, yes. Yeah, correct. Yeah, so it would be this, because so the and I guess also then I need to modify this guy as well to handle that. So this is actually the point, and I'll return the point. So once I slice off the first k elements, I'm going to map over the array that I created and just pull the point out, which is what this says.
Sure.
Cool. All right. Now this guy is math.how. So it's going to be now b is the point. We'll go with this for now. Point at 0 minus origin at 0. Now, yeah, I'm pretty sure it's point minus origin. I can double check that after versus origin minus point. Okay. Okay, so I wanted to do this, which is square rooting that plus this. So doing b, b2 minus b1, or this I guess is a2 minus a1 squared, and b2 minus b1 squared, adding them together and then square rooting that. So that should be the distance. Okay. All right. So I guess I'm pretty sure that this is the right order for these. I could double check that. I can come back to that at the end. I'm just going to kind of walk through I guess your example that you had down here and see what this looks like. I might. Cool.
And you're able to run here as well, so you could give it a shot.
Oh, okay. Oh, okay, cool. Okay, I guess I got to run this then. Okay, so let me just translate your points then into JavaScript. So points is, well, I'm just going to put this into a code editor so I can replace all the curly braces with square braces.
If you know Vim, you could do it here as well.
You can do that here?
Yeah, if you knew Vim.
I'm not
Oh, okay.
Yeah, I'm not super good with Vim. I know all my hotkeys and VS
Sure.
Code. I'm not. I'm like I can use Vim, but I'm not an expert.
Ah,
I can walk around the code and move some stuff, but I don't know advanced stuff. All right.
makes sense.
Now we should be able to call this guy points origin. Okay. So I mean, in the real world, I would be writing test cases for this stuff.
Which you could actually do as well. If you go to info,
which I
there's
totally.
a Mocha or yeah.
There's a Mocha. Sorry, where?
So if you go to left of JavaScript, there's an info button. And it outlines the built-in unit test library.
Oh, that's cool.
Yeah, if you want to use it.
That's cool. Neat. All right. Well, I may use that in a sec. I'm just going to run this just to see what it does. Sure. But I generally do write test cases. Okay, it didn't work. So I would probably I would have started.
Did you say it worked or it didn't work?
Oh, sorry. It am I reading this wrong? It outputted.
Yeah.
I'm not seeing the whole thing. Am I missing something? Oh, okay. Oh, the line was getting cut off. Sorry, I didn't see it.
Oh, okay.
Okay. It looks like. Okay, so it looks like it did work based on the answer. You gave me the answer, which was what we're seeing there. So it looks like it did work. Now, that's like a great to see that it worked, but generally I would write test cases, which I can do. I would have started by testing this function on its own. Let me see how the Mocha tests work. Okay, so I can just bit of a hack. All right. So before I do continue, I mean, this does work. It looks like for this use case, at least. I can write tests for it. I can try to potentially optimize the solution more. What would you like to see me do?
I would like to see it optimized.
Okay. Cool. So, all right. So what we have here, as I mentioned basically at the start, is that we have an n right here in terms of time complexity, and we also have space n as well. Okay, there's that. We've got an n log n here, and log n there. Another n space. Technically, actually, this does do an in place sort, but anyway, it's still n. Another n, and then yeah, we slice and map again another n. So like I said, coming out to n space complexity and n log n time. So can I improve on this? So I think that the answer is yes. So I do need to iterate over every point at least once, I believe, because otherwise I don't know if it's the closest or not. And I believe I need to calculate the distance for each of them. What I can do, though, is actually track the k closest points as I iterate over it. So I don't actually need to do this sort. I think the code is a bit cleaner this way, but I can optimize the time complexity down to just n by basically doing like greedily storing the top points along the way. So if I go with this idea, actually, let me just copy this to before I start destroying it.
Yeah, that's good.
Okay, I'm just going to go down to the bottom. Yeah, and just make a duplicate of it.
Just kind of curious, where are you at in your interviewing phase?
So I haven't done any phone screens yet. I've basically like done a bunch of preliminary calls. I have several phone screens set up as well as a couple on-sites. Okay. Starting like next week, I have several phone screens, and then I'm targeting some on-sites in the middle of November.
Nice.
Okay, so here we're going to have k closest points, array, and I can use a for loop. I think they're really ugly, but it does let me end earlier if we want to like really optimize it. So for int I equals 0, actually it's not int, let's I less than like right. I did actually just have a thought. That's why I paused here, because I think I could actually say k. Oh no, I can't. Never mind. I have to go through all of them. Okay. Okay. So I do that. Now we're going to get the point is points at I, and calculate the distance. Still this guy. We've got the distance now. Okay. So I've got the distance. Like I said, I can just kind of push these into the array. But that means every time I want to, every loop through every point that I check, I need to essentially look at all of the points inside of k closest points to see if this one is less. So I can also actually store, how can I do this? I can store the current max that's within the min, within the closest points essentially, which lets me know immediately if the current point is going to be less than or equal to that value. So it would be, a let cur max distance. Yeah. So this is essentially the max distance that's the closest.
Right.
Because what we're looking for is k closest. So if the closest were like 3, 4, and 5, the max would be 5. So that if I found one that was, anything less than 5, essentially, I would replace 5 then with like 2, and then I would update the max distance to 4 at that point. So that does allow me to not have to look through this every time. It does just mean that when I want to boot something out, I've got to find it and remove it, which is like up to k, but it should be faster still. Okay, so now if cur max distance, here's some funny JavaScript for you. So I have to check if max distance is null or distance origin is less than or equal to cur max distance. Then I want to add this point and potentially evict another point. Okay, hold on. So yeah, there's a couple of things here. So yeah, so inside of here, if the max distance is null or this one is less, then we want to add the point. Now we want to check if there's room to just add the point, or if we need to evict one that was already in there. K closest points dot length is less than k, then we can just push it in. K closest points. Push, and same thing that I did before, I'm going to have to add the distance as well as the point. And that, once I've done this, I should basically be able to get rid of this guy. Okay, so if the distance is null, the distance is less, okay, cool. So basically here we're saying if there are less than k points in there, we can just push it in. Otherwise, we need to first evict point. So I'm actually going to just change this a bit to make it a bit clearer. I'm going to change this to if it's greater than or equal to, I guess just equal, but can't hurt to be safe. If the points are greater than or equal to k, then we need to remove the max point. So here we'll index of max point is equal to this guy, closest point dot find index, and the distance to origin. And now I have a shadowing variable here. I would also probably split some stuff out into functions. I can do that after, but this is getting pretty ugly. Okay, so if the distance to origin, should this not go green? No? Okay. Is equal to the max or max distance, we can return this. Now, it is possible that there are duplicates as well here. I'm just going to note that down, possible duplicates. That will find me a point, not necessarily all of the points that are at that max. And I can now essentially slice it out. I think it's probably easier to just let me reassign this array equal to this guy dot splice. Can't remember if splice mutates or not. Just look that up. Never remember this. Splice changes the contents. Okay, so I actually don't need to do this. Splice actually just mutates the array. Splice from index of max point 1. So that will remove that element essentially from the array. And now I can push this guy into that array. Now, because there are duplicates, not even necessarily because they're duplicates, I essentially now need to find the new max distance to origin. So that I will do here.
Let's stop with this question. I kind of want to go push it a little bit further.
Sure.
The next part isn't really about code, but more about your problem solving and an idea that you can come up with.
Okay.
And I want to change the input from a list of points to a stream of points where the input is infinite.
Okay.
So there's an infinite number of points coming in, and
yep.
So I don't know if you know how the string works, but it'll start over and then you just do the same. What are some thoughts on that of how you would tackle that to return the k nearest neighbors when it's infinite?
Yeah. So like, can I use like an observable for this?
An observable. What do you mean by that?
Like as the data structure. I mean, so I would I'm pretty familiar with like Rxjs. So when you say, a stream, I would model it probably as an observable with Rxjs, because that's just,
Yeah, I don't know but yeah, that's fine.
It essentially allows me to operate on a stream of data using, things like map and reduce, buffer, etc. So anyways, that's just, I'm going to think a bit more about how this will work though. So we've got a stream of points coming in and we want to find k. So k is fixed, but the points are just coming in over time and eventually will potentially complete. I mean, I assume it has to complete at some point if we want a result to this. Otherwise, I
Right.
could probably just return the top. I mean, I can return the top K to date. If you want me to do that, kind of every time a new value comes in, I can return the top K, like up to this point, the K closest, or I can wait until it completes if we know that it will complete.
So
Which would you prefer?
it won't
Yeah,
ever complete. And I don't
it
want to
won't ever
return.
complete.
Yeah, the input will never end. So
Okay,
what I want isn't to return the top K at any given point. It's to at some point quit and say this is the top K.
okay. And how are you going to notify me that it's done? So at some point you want to stop.
Well,
So if you give me a stream, there's, yep,
I was gonna say I want you to decide when to quit. So I want you to come
you
up
want me to
with
decide. Okay,
yeah, I want you to come up
a
with
way to stop
something
it.
that says yeah, something that says, hey, I think I've seen enough. Here's the top K.
Sure. Yeah, I've got, I can do that in different ways. I can just do, when a certain number of points have come through, I can do after a certain amount of time. Um, either anyways, it doesn't really matter. So, okay. So I stop it at some point, and return the top K. I think, so basically what I came up with here was sorting. Originally was using a sort. And then we kind of moved to this one, this sort of greedy algorithm, which makes more sense when you're looking at an infinite stream of points. Obviously, you can't just like sort them with an infinite stream. You just
Right.
want to store the top results that you've seen to date. So this sort of approach makes a lot more sense.
Yeah.
So so it's going to be something similar to this idea, but essentially just translated to using streams. Uh, can I use how do you want me to model this? Like I can use Rxjs, which the API I know. I don't know if I'm able to require random libraries here. I don't know if you want me to try to because I need
Um.
to model the stream somehow. I mean, I can spend time doing that, but I don't think that's a great use of time
I
unless
you can
unless you do.
RxJS works. I don't actually know how that works, but yeah, by all means, feel free to use that or something else.
All
Um,
right. Am I able to include stuff here? Or it's just libraries
yeah.
that are
Actually, I don't know, but yeah, feel free to try.
okay. Yeah, it doesn't look like I can include just my own any npm library here. So
Yeah,
it's
Java and stuff you
it
can.
won't
So
it won't run. Interesting.
yeah.
I mean, I can try to just require it and see what happens. It might just blow up, or maybe it'll work. Let's try it.
Well, this
Rx.
last part really isn't about code. It's more of your thoughts on
Right.
how.
Okay.
Yeah.
Got it. Okay. You want me to just, okay. I mean, I would use Rxjs for this, which allows me to basically model a stream input as well as operate on it using, there's built-in operators. I can write custom ones as well. But essentially, the thought process behind it, if I were to kind of write steps, is to at each point we want to pass to the operator essentially in my stream. My stream operator will want to receive the top K points to date, as well as the current point that I'm looking at, and I would basically do this logic here, just kind of inside of a stream operator, and then I would update K. So how would that work? Essentially saying that yeah, the trickiest part here that I'm thinking of is trying to think of how I update K and kind of pass it back into the stream, into my operator. I actually, no, I can do the operators can be stateful. So I would essentially write a stateful operator that has a K in it that I initialize with a K. And as it receives points, it's basically just kind of looking through its internal like k closest points array. Doing this basic logic here to determine if it should be evicting a point or adding the point into it. And at some point later in time, when the stream completes for whatever reason, and I can set that up, like I said, different ways. But whenever the stream completes, and it can complete, say, based on 10 minutes have passed or whatever we want to do, I would just return that point, the points array, sorry, that I have.
Yeah.
Does that make sense? Does that answer your question?
That makes sense. So I'm not sure if I caught all of that when you quit,
Yeah.
but everything so far made sense. So is there like some sort of like error ratio with that, saying, hey, here is what the top K are, but with a potential error ratio? To say, hey, I think I've seen enough to justify the top K.
Right.
Yeah.
Right. So, I mean, what is this? If I'm going to be talking about error rates, like what is this a stream of that I'm looking at in order to determine, like, when I'm stopping the stream. So, what I've explained so far is like how I would do it from a technical standpoint, in order to basically say I can return the top K. Great. So we've got that covered. So I guess this part of the question more pertains to what is the like context of the question. What are these points? And what is this stream? And based on that, I'll try to give you an answer.
Well, the points is just the input stream of XY coordinates or XYZ or whatever, right?
Right.
So,
so
what I was thinking here, at least my perspective is, hey, what if we have some sort of like sliding window of, hey, I've seen so many points and I've seen the max of this, so I feel confident to return something like that. Any thoughts on that?
Sorry, so you're saying we have a sliding window, and based on previous windows, like what I don't quite understand. Yeah, so I'm based on the windows I've seen to date, trying to determine if it's a good spot to, or like what the error rate is on, like I don't, if it's a sliding window, then I'm just returning the top K points within each window, right?
Yeah.
So what do you mean? Like I'm a bit confused by this question, by this part of the question.
Yeah. So trying to put it in a good way. So my thoughts are this. Hey, if I am not on that screen apparently. There we go. Let's go down here, right? So let's say I have a sliding window with two things. Let's say a number of points. Let's say the first one will be 1 billion points. The next one will be max distance. And I'm going to start out with like 0.001 away, right?
Yeah.
And I'd say, hey, if I've reached 1 billion points and my max distance is 0.001, then we're done.
Yeah.
If not, let's increase and say this is now 1 trillion, but now this is 0.1 or something, and so on. So it kind of keeps shifting over until both are satisfied, right?
Okay, so we're looking to end. So it's base. You want me to end based on like what satisfies each criteria, essentially, I guess is the question. So you either want to see a max distance like over a certain value, like what. So when I visited 1 billion points and my max distance is 0.001, like why do I decide to continue?
Well,
to
if it's under, then you just stop. But if one of those is over, then you shift over, right?
I see. I think I understand. So you're saying that that's the threshold, essentially. You're saying that 0.001 is kind of a threshold that we're hoping it's going to be under. And if it's not, we want to then like take a bigger sample size, and then the threshold will increase as well.
Yep. At least that's my thoughts on
Okay.
it. So that was more of a discussion of seeing, hey, what would you do in this case? So let's stop here. It's been roughly 35, 40 minutes.
Yeah.
And now we can I could give you your feedback. We could discuss it. We can you can ask me any questions you have. If that sounds
Sure.
good.
Yeah, that sounds
So
great. Yeah, I love feedback.
awesome. So I actually don't have anything negative to say, to be honest. You did really well. Like you're fast. You came up with a good starting solution. The only thing I wish you would have done for the second part was say, hey, let's store it in something efficient like a priority queue, to where you can see the max element in all one time.
Right.
Basically,
Right.
max heap. Um, you
Yeah.
consider all the edge cases. You said, hey, we're going to test this out. Here are the cases I would test with. It works pretty. Actually, I don't even know if you ran any errors, or if it worked the
No,
first time. Um,
it did. It worked the first time.
that's impressive. I don't think I've ever heard that. Your code is clean,
Beginner's luck.
right?
Yeah.
Your code's clean. Like the way you logged everything. It would have been neat to see you try at the unit test, but it's not hit or miss. It's
I mean, I know how to write unit tests. It's
yeah,
like, yeah.
yeah, yeah. Except for the wishing. Actually, there's a couple of things, but except for the wishing you pointed out a priority queue instead of keeping an active list.
Yeah.
Um,
Right.
Good. The only other thing I would say, you're missing the edge case of when k is 0. And
Okay.
also, would you have approached this differently if I said, instead of 2 dimensions like x, y, let's give it a million dimensions. So x1 to x1 million.
Right. I think that you need to do, I don't know, off the top of my head, I think that you still like the distance formula, I believe, is basically the same. I think you just add more like elements into the calculate distance.
Right.
You need to just look at every dimension of it rather than just two.
What about this part?
I guess the space is going to be a lot bigger for the points, potentially. So, using n space is going to just be like bigger. With a million dimensions, duplicating the points is going to take up a lot more space. I think I kind of solved that with my second implementation, which was more of like a greedy algorithm. But yeah, I definitely, that makes sense. Like if there's potentially a lot of points and the dimensions are high, it's going to use up more memory.
So kind of what I'm thinking is just index instead of the point. So store the index.
Right. Fair. Yeah.
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 Beyond that, you did really well. I would have totally passed you both on site and the phone screen. So nice job. Do you have any questions? Any comments?
Yeah, I'm curious, like, how many interviews have you done? And like, because you say I've done well, I'm just curious what your sample size is.
I don't know the total number, but I'm probably over 500 now. Not just here, but
all right,
like
that's pretty big sample size. Yeah.
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 Yeah, not just here, but
Cool.
my jobs themselves and everything else. Like I'm probably over 500. I've done a ton.
Got it. Cool.
And
Okay, well that's good to hear. It makes me feel yeah.
It takes a lot for me to
believe it or not
for someone. So.
Okay.
Cool.
Well, that's good. That makes me feel good that I have these. Yeah.
Yeah.
Go ahead.
If you perform like this with your future interviews, you'll be fine. So hopefully this helps get rid of some like nervousness or anything that might come up.
Yeah, it definitely helps.
Yeah.
Doesn't hurt, that's for sure.
Yeah. Well, any
I
other
think that's
questions
pretty
here?
good. I think you were a good interviewer.
Great.
I think that was pretty good. If you're open to, do you live in the Bay Area or where are you from?
I'm in Seattle now. I used to work at Google and
You're in
Microsoft,
Seattle. Okay.
um,
Yeah.
but I'm
Cool.
making companies moving to Boston now. So
Okay. Cool. I'm actually, this is just random curiosity questions, but what has you interviewing on the platform? Like, is it for experience? I mean, it sounds like you have a lot of experience interviewing. Why do you do it?
I actually started up a nonprofit to help people get into tech, and
Okay.
Elaine, the CEO, reached out and said, "Hey, you like giving interviews? You like helping people out? We have this really cool platform that works a whole lot better than what you're doing. Uh, do you want to give this a shot instead for that portion of it?" And I said, "Yeah." So it's a really neat platform, and also we get a little bit of a kickback as well. So uh, just kind of a thank you for helping out.
Got it.
So,
Cool. All right. Well, I think that's good. I appreciate the feedback a lot, and I really appreciate you taking the time.
sure.
It's very helpful for me, and yeah.
So I'm gonna write some written feedback. It's gonna be along the same lines, and at the end you'll get the chance to write me some feedback. I'm gonna, since it went so well, I'm gonna say showcase it. What that basically means is
Okay.
there's a list of videos on the site that say, "Hey, here are good videos uh, we want to show other people." Completely anonymous still, but if you want to do that, you can select that showcase as well, and it'll go public.
Cool. Yeah. I'm.
So,
Why not?
sure. Awesome. Well, it was a pleasure. Have a good weekend. It is weekend. It's Thursday. So, yeah, nearly weekend.
It's almost the weekend. Getting there.
Yeah. Take care.
Well, thank you, and thank you, Indelible Raven.
Yeah, no problem. Bye.